if you flip it to the back, we're going to deal with circles not in standard form. Okay? Not in standard form is where they did all that solving for you. They took an equation written like this, FOILed both parentheses, combined like terms, and then they get this jumbled mess here. With lots of x squared, y squared, x and y, and numbers, which is all jumbled. We used to use this process called complete the square to take this jumbled mess here and make it look like that. Right? But Desmos came along and made our lives a lot easier, so we can actually just use Desmos to do this instead of complete the square. And it's really similar to that last example we just did. So go ahead and get out Desmos. I'll pull Desmos up on my screen. Here. And delete what's there. And it's really important that your screen, 5 and 10 are on your screen. I really suggest using a Chromebook or a laptop because your phones with the Zoom, it gets messy. But 5 and 10 need to be on the axes. If it's not, you're not counting by ones. So if it's like 2 and 4 and 6, just zoom out. So 5 and 10. You have to be counting by ones. If you're not counting by ones, you will miscount. You'll make things bigger or smaller than they need to. Because again, when we count 1, 2, 3, 4, 5, okay, that makes sense. I landed where I need to be. If you're zoomed in, let's say 2 and 4 are on your screen. Whoop. If 2 and 4 are on your screen, like this, you're not counting by ones, right? If we count 1, 2, 3, 4, so that says 2. You're actually counting by a half, which can be hard to count by. So just make sure, my rule of thumb, make sure 5 and 10 are on your axes. If it's not, zoom in and zoom out so they do. And then that way you're counting by 1. Okay, so make sure 5 and 10 are on your screen or you'll miscount. All you have to do is type this in exactly how it's written. Type it in exactly how it's written in the Desmos, and it will graph the circle for you. So we have x squared minus 10x plus y squared plus 8y plus 16 equals 0. Oh, put it exactly how it is. Yes. Oh, so hit the home button. And then hit zoom out. There we go. Yes, you can also, if it's like super zoomed in or super zoomed out, hit the home button. And then you might have to zoom in and zoom out one more time. So just make sure 10 and 5 are on your screen. So it graphed it for us. Now this is exactly what we did on the front. To get the center and the radius, we just count. No different than we did on the front. You can even click the circle. You notice how all those points line up? Pop up on the circle? Pick the ones that are across from each other and look like they're going down the middle, which is here and here. So we just have to count. What's all the way across? 10. So to get the middle and the radius, cut it in half. What's half of 10? So our radius is 5, and there's our center. What are the coordinates of our center? 5, -4. So our center is located at 5, -4. Our radius was 5. Now we can write the equation. Just like we did on the front. X change the sign. Squared plus y change the sign. Squared equals what? 25 radius squared. And there we go. Again, change your signs when you plug it in. Square your radius. And then when we graph, just plot your center, 5, -4, and count your radius in all 4 directions. Up 5, back to center, left 5, back to center, down 5, back to center, and then right 5. And there we go. Questions over that. Same kind of thing for B. We want to write this in standard form. Well, graph it. Go back to Desmos. Clear out what's there. Type it in exactly how it is. X squared plus 4x plus y squared minus 6y equals 23. Okay, you don't have to worry about solving for anything, moving anything over. You just plug it in exactly how it is. And it'll graph it for you. So again, click your circle. Find those points that are across from each other and count. All the way across is 12. So what's our radius? 6. And then that will tell us where our center is. Where's our center located? -2, 3. Very good. So our center is -2, 3. And our radius was 6. So when we write our equation, again, x change the sign squared plus y change the sign squared equals what? 36. Radius 6. And then when we graph it, again, you're just regraphing what was on Desmos. So -2, 3. And then count your radius. Up 6, back to center, left 6, back to center, down 6, back to center, right 6. And connect. Questions over that? Hit the home screen.
Like, if I type something and then it'll only show for something and then it'll go one.
Oh, you have to type the whole thing. It does disappear. So once you type the whole thing, it will appear.
When I did it on my phone, it stayed on. If I typed the whole thing, when it was on the phone.
Let's see. We'll try another one and see. So go ahead. Type this in. But sometimes we don't want to know the entire equation. We just want to know part of it. It might give you this and say, hey, what's the radius? Or hey, what's the center? But the steps are still the same. So go ahead and type this into Desmos. Or go ahead and type it in and I'll see what happens. So x squared minus 16x plus y squared plus 10y plus 80 equals 0. And you might have to shift your screen around a bit to find it. And then start counting. There you go. And then good, keep it at 5 times. You're counting by 1. So to get the center, click your circle, count all the way across. All the way across was 6, which means our radius is what? 3. There's our radius. Our radius is 3. It also tells us what our center is. What are the coordinates of our center? Negative, or what is it? -5 is the y value. What's the x value?
I don't know.
8. -5. 8. So our center is 8, -5, and our radius was 3. So sometimes, often what I see on the OST, they will give you something like this, and they'll be like, what's the radius? So all you have to do is just graph it, count across, cut it in half, you have your radius, move on to the next one. Right? We used to have to do this really long process, and now it's much quicker. The next example, we want to find the circumference in the area of this circle. Well, the formula for circumference is 2 pi r, and the formula for area is pi r squared. For both equations, what part of the circle do we need?
The radius.
The radius. Exactly what we've been doing. Type this into Desmos. And sometimes the equations are really long, sometimes they're really short. Right? So go to what? Go to Desmos. Plug it in. So we have x squared plus 8x plus y squared equals 20. Again, click your circle. Count. All the way across is 12, which means our radius is 6. Cut it in half. So then you just take 6 and plug it in for r in both equations. We want the exact answer and we want the rounded answer. So to get the exact answer, just multiply the numbers. 2 times 6 is 12. So 12 pi is the exact answer. To get the rounded answer, just plug 12 pi into your calculator. And we get about 37.7. The area, again, just plug r, or 6, in for r. The exact answer, just square the 6. What's 6 squared? 36. And tap on the pi. So that's the exact answer. To get the rounded answer, just plug 36 pi into your calculator. Oh. 36 pi, which is 113.1. And there we go. Questions over that? Last examples are pretty quick. Again, there used to be, before Desmos existed, we would have to do this algebraically. We'd algebraically have to determine if those points lie on the circle, inside the circle, or outside the circle. But we have Desmos to make our lives much easier. So all you have to do to figure this out, or what do you think you have to do to figure this out using Desmos? You could just plug in the point, plug in the equation, and see where it lies. It's that easy. So I'm going to type the equation on my circle in. Type it in, which is x squared plus parenthesis y plus 1 close parenthesis squared equals 25. It graphed it for me. Then plot that point. To plot the point, put a parenthesis. You have to put parentheses in Desmos when you plot points. We have the square root of 2. Make sure you arrow out of that square root, comma 1. Where does that point lie? Is it inside of the circle, outside of the circle, or on the edge of the circle? Inside. Yep. Anywhere in this area is inside. Anywhere, like in this vicinity, is outside, right? So anywhere in this area is outside. Anywhere in between the edges is on the inside, and on the circle would be like these gray points. That's on the circle. That's on the circle. If it's on the edge, on the line of the circle, it's on the circle. Okay? So this one would be inside. And then let's try one more. Again, graph the circle. Which is x minus 2 squared plus y squared equals 20 squared. Then type in your point, parentheses, -3, comma, square root of 5. And where does that point lie? Outside the square. We would just say outside. And again, we'd have an algebraic thing to do. You'd have to plug the point in for x and y and then see what you get. If it was equal to the if it was equal to this number, it would be on. If it was greater than this number, it would be outside, and if it was less than that number, it'd be on the inside. But that's what makes it easier. Plot. Graph. Give you the answer that. Questions over that?